All right, let's look at example 7 here. This is a great test problem. Great test problem in example 7. Shows me that you understand the formula and can do a little bit more of an application with it. So when I do this test, I don't try to do the most basic problems. I don't sit here and try to say, find the area of a circle with radius 3 inches. I try to make it a real world problem. Like, I don't know, you have a pivot that works and waters a garden. Well, a pivot has a fixed point and a length, so when it goes around, it makes a circle. So I could say, what's the length of the outside circle? You know, the circumference of this circle for this pivot, for this exact thing. Of course, I give you a picture and I'd make sure you understood it, but the idea is I would rather you have the application problem of perimeter rather than just straight up a problem that says, a circle has radius 3 inches, find the perimeter. Look for those applications. So number 7 here is a great example of one of those applications. It says a bicycle tire has a diameter of 24 inches. How many feet does the bicycle travel when the wheel makes 8 revolutions? Round to the nearest hundredth of a foot. So what's the idea? You have a bicycle tire and you're going to drive or ride that bicycle. When you ride that bicycle, each revolution is a circumference. Well, this is telling us we're making 8 revolutions. So what we need to do is find the circumference of the circle, and then we need to multiply it times 8. Okay, so whatever we get for this circumference of the circle, we need to multiply it times 8. There's some other things that I want you to realize. I want you to realize that it says how many feet does it travel. So I need the answer in terms of feet. But when I look at this, I have a little bit of an issue with that because look at the measurement they gave us. They gave us a measurement in terms of inches. When they gave us the diameter of this was in terms of inches. So the question then becomes, how are we going to get from inches to feet? And the answer is, well, there's a couple ways we can do it. We can do it immediately at the get-go, so we only deal with feet, or we could do everything in terms of inches and then convert it at the end in terms of inches. I'll recommend to you that the fastest way to do it, the most accurate way to do it, the way that students do it best, is if they convert inches to feet immediately. So we need to go from 24 inches to blank feet. How many feet is it? Well, if you start off and you do your conversions like we've looked at already, 24 inches, we know that 12 inches are in 1 foot. There's our conversion ladder, inches cancel, and what we're left with is 24 divided by 12, which equals 2 feet. So this bicycle tire, rather than looking at it as 24 inches, we're going to see it as 2 feet. Now our measurement is in terms of feet, which could give us our circumference in terms of feet. So the circumference again would be 1 revolution. What's the circumference? Well, we have the diameter of 2 feet. So if we want to do the circumference, we should probably use pi times the diameter formula because we're given that diameter. So for 1 revolution, the circumference is going to be pi times 2 feet, which is 2 pi. Remember, that's exact. And in a problem, you never want to round until the very last step. Okay, so let's think about this. We have that 2 pi feet are in 1 revolution, but the problem is we have 8 revolutions that we need to do, right? We need to go around 8 times. So how far is that going to be? Well, using our conversions once again, that's going to tell me that I have 2 pi times 8 feet, which is 16 pi feet. That's the exact measure. But then let's go back and reread the problem. It says the nearest hundredth of a foot. So that tells me I need 2 decimal places. So what am I going to do? I'm going to put in 16 pi into my calculator. If I hit enter, it just gives me 16 pi. Again, hit that double arrow button and it's going to give you the decimal approximation. I'm getting approximately 50.27 if I round properly. 50.27 feet. Okay? So if you had rounded earlier, 50.27 feet, putting that in the answer blank. If you had rounded that earlier, for instance, where it says 2 pi, if you had rounded 2 pi earlier, you potentially would be off by a couple decimals on your final answer. So the earlier you round, the more inaccurate your final estimation is. So never, ever, ever round until the very last step. Otherwise, you'll get frustrated by being off by just a couple decimal places. And that would be why, because you rounded too early. All right, so let's look at another example of that. It says a tricycle has a diameter of 12 inches. How many feet does the tricycle travel when the wheel makes 12 revolutions? Round to the nearest hundredth of a foot. So again, here we have a wheel, and we know that the diameter of this wheel is 12 inches. What's the problem? That's given to us in inches, but they want the answer in terms of feet. So the first thing I'm going to do is I'm going to put feet there. I also noticed that they want it to the nearest hundredth of a foot, so I know I need to use 2 decimals. Again, a revolution of this tire is the circumference of the circle. So I need to find the circumference of the circle, which would be twice the diameter, pi times the diameter. I don't know why I wrote that. Pi times the diameter, because we're given the diameter. Again, we have our issue here that we start off in inches, so we need to convert from 12 inches to feet. When we know that there's 12 inches in 1 foot, that simplifies, and 12 over 12 is 1, so we're getting a total of 1 foot. So the diameter we're going to use, rather than it being 12 inches, rather doing pi times 12, we're going to put our answer in terms of feet, so we're going to do pi times 1 foot. So the circumference here would be pi times 1, which is pi, and again, that's in terms of feet. So again, we know we have pi feet in 1 revolution, but the issue is we need to make 12 revolutions. So if we do pi feet times 12, we would have pi times 12, or 12 pi, but that's the exact answer, and this wants us to estimate it. So I'm putting 12 pi, hitting the double arrow button and enter, and I'm getting approximately 37 point, well, if I round to 2 decimal places, technically it would be 70, but you never put the trailing 0. So again, it should be 70 if we said to the hundredth, but never put that trailing 0 in a real world problem like this. Only put that 0 for money. Never put that 0 for anything else. So I'm getting approximately 37.7 feet. That is rounded to the nearest hundredth. Just to let you know, if you put 0.70 on the test, while technically it's incorrect because it's not simplified, I would give you credit because it did say to the nearest hundredth. Okay, so let's go on to the next topic. We talked about perimeter being the length of the outside. Now let's talk about area. An area is the amount of surface on the region. So it's the inside of a 2-dimensional figure. Area is measured in square units. Very, very important. So just like I talked about perimeter, I want to talk about area to the side. So when you see the word area, you should be thinking about the inside of 2 dimensions. Okay? When we did perimeter, it was all addition. With area, it's all multiplication. With perimeter, it was just the unit. With area, it's going to be the unit squared. So for instance, inches squared, feet squared, or meters squared. Whatever it is, anytime it's area, you know your answer has to be that unit squared, and that's something you could do immediately. Okay? So let's look at this. It says a square that measures 1 inch on each side has an area of 1 square inch, or 1 inch squared. A square that measures 1 centimeter on each side has an area of 1 square centimeter, written 1 centimeter squared. Larger areas are often measured in square feet, square meters, square miles, which are acres, which by the way, an acre is 43,560 square feet. Another wonderful conversion for this. Or any other square unit. Okay, so how do you find the area of a rectangle? Again, instead of adding them, we are now multiplying them. So the area of a rectangle, yes, I do expect you to know this formula, is length times width. Let's continue with more area formulas on the next page.